If you remember your trig identities, you might recognize if you multiply together two sine waves, the result is the sum of two cosine waves, and these cosine waves have frequencies that are the difference and the sum of the two previous frequencies. Now if we want to turn these into sound waves, the average human can hear between 20 and 20,000 hertz. So if our starting sine waves have frequencies on the order of 50,000, then the sum cosine wave will have a frequency around 100,000. We won't be able to hear that. What we will be able to hear is a tone that has a frequency that's the difference between these two. Now how is that useful? Well, if we start with two waves that have the exact same frequency, then we can hear how different they are audibly. For example, here I have an LC oscillator circuit. There's an inductor and a capacitor, with the inductor sticking out here. Feeding into that, I have a reference signal with a frequency of 57.8 kilohertz. Now this inductor is made up of a wire loop. Now the magnetic flux through a wire loop is heavily dependent on if there's any material in the loop, because some materials interfere with magnetic fields. Now if we can interfere with the magnetic flux in a wire loop, that means we can change its inductance. If we change the inductance, we change the LC time of the circuit. And if we change that LC time, then suddenly there's a difference between our LC frequency and our reference frequency. What this means is if I put a piece of metal into this loop, we'll be able to hear it. And we've effectively created a metal detector.